Okay, good morning, everyone. I see people are slowly trying to stream in. So meanwhile, while everyone's coming in, I'm going to provide a very short introduction. But in the meantime, while everyone's coming in, feel free to type in the chat where you're coming from. The chat will also be our way to ask questions. So make sure that that's working well. So just let us know where you're coming from. Now, I see that we have 35 participants and counting. So let's start slowly to let more people come in. So good morning, everyone, and thanks for joining. I'm Rob Curlio from Trust IT Services and the events manager of EO4EU, and I'll be your host for today. So last month, a new European Union funded project, EO4EU, was launched aiming to develop a new platform which will make access and use of Earth observation data easier for environmental, government, and even business forecasts and operations. Today, you will hear directly from the coordinator and the leads of the various activities what the EO4EU platform is, why it is needed, and how it can benefit you, and how it will be developed. But first, some reminders. So remember that this is a recorded webinar. So however, you will only appear in the recording if you speak during the Q&A. Please keep your questions until the end, though, only the Q&A part, in case your questions are addressed in later slides. The slides and recordings will be published on our website as an on-demand webinar on right in our site, eo4eu.eu, within a week of the webinar's live broadcast. Please feel free to share this webinar in your social accounts and make sure to tag us there. So let's have a rundown of the agenda. So first, we'll have Vasileios from ECMWF, who is the EO4EU technical coordinator, who will talk about where Earth observation data can help. So this is a landscape overview. Then this will be followed by our project coordinators, that is Hadjistimiadis from NKUA, who will be introducing EO4EU. Then we will go into a panel discussion with the work package leaders and the coordinator. So among the work package leaders that will join us is Jota Lilly from EBOS, who leads the requirements elicitation and conceptual framework specification activities. We have Dr. Vasileios again, who will talk about the data orchestration and machine learning work package. We have Giuseppe Trotta from Cineca, who will talk about the EO4EU data marketplace ecosystem work package. Then we have Monia Santini from CMCC, who will discuss the EO data uptake demonstration work package, and it will be moderated by yours truly. So with that, I think we can pass the floor to Vasileios. So Vasileios, you can now share your screen. Okay, that goes well. So unmute.
Okay, perfect. Good morning from my side. Welcome to our webinar. So actually this presentation about to set the scene about what is the EO4EU project is trying to address. So with Earth observation data, actually in the recent years we have seen a lot of data becoming available, and also new theories, new tools are emerging with machine learning, with other tools processing big data. And actually that give us the possibility to explore and create valuable knowledge that will understanding better some parts of our planet, atmosphere, marine, and etc. And actually give insight to some other areas that were difficult to be processed. All this data actually reside in repositories, and there are plenty of data services. And actually the access methods of this data are different, and also format data, and all these things are not that easy to access and the process. That is the reason why most of the users of this service are scientists or Earth observation data or numerical weather prediction experts that use this data and create the value-added services. There are plenty of programs. Probably most of us will know about the Copernicus program, Galileo, EGNOS, and Inspire as well. And actually, all this, and also I'm going to talk also for the upcoming Destiny program that started a few months ago. And all these are used by various experts. And the reason of EO4EU is to make this available easily to a wide range of end users. So there are, for the Copernicus, I'm going to focus mainly on the Copernicus data and how these are make available the data and the services. So there are few platforms called DSS, Data and Information Access Service, that actually make available this data. There are 5 existing ones, but and all of those provide a similar service, access to data, and also, as we can see later on, what they do is to provide access to data, services, also cloud infrastructure because of the data. There are also some visualization of the available data, and users can retrieve the data. And also, in addition to that, there are some professional services that actually this is the business model of most of the DSS to offer a tailored cloud service solution and tools. But the thing is that this diversity of DSS, at least the first version and second version of this platform, so it's the users have a completely different experience when they access and try to retrieve data from there. And there are different catalogs, discover methods, and visualizations are different. And actually, as I said before, is even the business model that are a bit different. Not to mention also the APIs, because this is no standardization there. However, that was also the purpose of this DSS, so the diverse different models and different approaches that at the end we let's say the most appropriate model to be selected, and this is for more or less what is happening now. So most of them, they don't provide any semantic annotation to data and ways to for data mining. The data fusion mechanisms are not that easy to. Most of them they don't exist. Advanced cloud infrastructures or like GPUs or Kubernetes are not that easy to be provided from most of these platforms. And also the introduction of the new tool sets or supporting tool sets are difficult to reach the end user from the initial requirements statement from the users till these tool sets to be available to the end users. So in general, these are Earth observation data services, including WP, actually, as I will see later on from Copernicus, from Destiny that is coming soon, that provide enormous data volumes. So there are some things that needs to be taken into account in the future: the simplification and homogeneity of standardization of data access. Also, the use of machine learning algorithms to data mining, data fusion, data compression, as we would see later on, might help a lot in improve the data access and data processing. Semantic analysis is another part that is not properly addressed and tackled in these platforms. And also, because we are talking about the European Union initiatives, so there might be some synergies with the big initiatives coming from industry like GIX and IDS, but also European Open Science Cloud and also Destination Earth, which are actually steered from European Commission. Also, cloud services, sometimes we believe that infrastructure as a service is good enough for that, but I think that there are huge demand to users to have access and easily create their own resources and virtual resources and be able to flexibly process their data and actually keep up with the technology and the evolution of this thing. So I talk about the Copernicus data about, but also Destination Earth is an upcoming program from European Commission. This is entrusted to three core partners, ESA, HumanSat, and ECMWF. All of them have a totally different role and fulfill different parts of the program. So we have ESA, which is responsible for the cloud infrastructure and user access. We have also machine learning might be also there, customize the user environments. The data lake will be developed by HumanSat with the data handling system with bridges that they're gonna, let's say, make available data from the digital twin. At the core of this program is the digital twin that would be a responsibility of ECMWF with extreme digital twin and extreme and climate change twin. And also the glue that ties all this together and make available to the data lakes and the users. So the timeline, as we can see there, it's more or less close to the of the first phase to the EO4EU project. So and we just to have access to this data as soon as they become available, as since ECMWF is a core partner of this program. So that is the approach of EO4EU. We have seen on the left-hand side, we see all these data sources, Copernicus and other DSS and Destiny, and with a different APIs, each on all of them. So we try to glue this together and to make available through some front-end mechanism for with XR, with a DSL, domain-specific language, with a graphical user interface, command line interface, and the APIs to a wide range of users, not only advanced users, so the use cases that we are that we're going to mention later on, but also to simple users that make use of this data with a very simple way to retrieve and use it for their own purpose. So this is more or less we're going to see this diagram later on various presentation of the work packages, but this is what we would like to achieve and actually engage and helping the user uptake for all these data sources. The difficult part is the volume of this data that needs to be tackled in a way that can reach the end user, and this is what we're going to be discussing today. So this is more or less in the infographics of EO4EU. Probably all this will be analyzed later on from the status and the other work package leaders, and this is only for reference. And the only thing that I would like to mention is, so all this data, all this Earth observation data are available to these distant pilots, but our aim is not only tailored to this specific use cases. We would like to build, the design is to build a platform that is generic enough that any use cases can interface with the platform and get data in the same way like all the existing use cases, and not only use cases but also simple users, so that they would like to retrieve easily data from all these data repositories. And that was all from my side. Thank you very much,
Vasilios. Next up, we have Professor Stathis Hadjikymiadis, who will introduce EO4EU. So, Stathis, you may now share your screen. Okay, we see your desktop, and now that displays well. Thank you. I think it may be in mute.
Sorry. So good morning all. Again, this is Stathis Hadjikymiadis. So I'm the coordinator of this joint effort to boost the use of Earth observation data through the platform that we intend to develop. So I will provide a short intro into the project itself, try to highlight some technical aspects, and these items can be further elaborated later on by work package leaders. Okay, just an overview of the spatial distribution of partners. There are institutions, companies joining forces in order to address this boost on the use of Earth observation data from all over Europe, different disciplines, different competencies are combined in order to be able to provide a platform which fulfills its basic objective. So you can see here partners from all over Europe. Again, the infographics, let's say this part on the consortium. So we're discussing about 18 partners and quite diverse blend of partners, many universities, small and medium enterprises, research institutions for sure, and larger organizations. We do have the required expertise within the consortium in order to be able to implement the vision that we do have about this boost of the Earth observation data, facilitate the life of developers, and the, of course, the final output, which is intended to be used by specific users. So the basic vision that I mentioned previously was to try to provide a data ops, data operations ecosystem in order to enhance the access of the diverse sources that were mentioned previously by our technical manager, Vasilis. But also provide the tools that would facilitate the development of applications on top of these data. So we are addressing both aspects here. A wealth of data that are available here and there need to be accessed in a more systematic way, a uniform way, etc. Need to be fused through our platform, through these pieces of software that we intend to develop. And finally, the applications themselves can be developed in a more easy way. So to do this, we intend to set up a very specific architecture with different layers where these layers are to be enriched by modules coming from example from machine learning, stuff like that, that would enhance the knowledge about the sources themselves, enhance the processing that the different data should be able to undergo, and finally be able to deliver all of these in a systematic way to the applications or as an advanced user interface to the interested parties. That would allow, since we are building a platform from scratch, since we are embedding items of AI and artificial intelligence and machine learning, that would allow us to provide more information on the types on the type of processing that we are applying there. So whenever we are supporting decision making, this is to be sufficiently blended with all the required information. To be able to achieve this generic nature of the system, that will be we will be allow the interested parties to establish pipelines through our software, through our platform, that would filter progressively all the data coming in from the sources in order to deliver the really required outputs to the users. Again, in order to verify that, okay, this exercise was sufficiently addressed and successfully addressed, we intend to support a wide range of applications, a wide range of pilots throughout the duration of the project. Vasilis also mentioned, already mentioned 7 of them in many diverse fields. So this is an exercise that we intend to take in order to be able to, as I said, to show that this thing really works and really limits the workload of the Earth observation data developer, application developer. And of course, other items are on our research agenda here, development agenda, in order to be able to provide all these quite complex platform. Let's say that this is a layered a view of our layered architecture. You can see on the left-hand side an orchestration language which allows the user of the platform to be able to orchestrate many different modules in an application-specific ad hoc way. Then we have at the very bottom, we have the sources themselves, quite a few that are interfaced towards the platform and somehow bridge between themselves in order to be able to provide the really meaningful input to the processing which is to follow. Then we have the core infrastructure, the core processing infrastructure, which, as I said, is a combination of many different goodies, like, for example, fusion schemes that would allow different sources, heterogeneous sources, to be combined, but also combine these sources to in situ data, sensor data, being provided somehow either in real time or from existing repositories. Then we have the semantic part, which is trying to identify within the Earth observation data information, extract information, provide these to the applications in order to expedite their subsequent processing. Compression is one important aspect here, so there will be modules dealing exclusively with compression within our this processing infrastructure that we list there. And also knowledge management, the capability to accurately depict the kind of information which is to be fed by the sources themselves, but also the processing which takes place within this layer, reuse that at a later stage in order to achieve the same objectives as stated previously. Lastly, we have the upper part, the customer-facing part, which has one important ingredient, the so-called application programmable interfaces, which is allows the feeding of all this data, the data that had been filtered and processed by our platform, to be delivered to more detailed processing, which is part of the very specific vertical applications. Apart from that, we have generic infrastructure like dashboards and the capability to engage on very specific data processing workloads, reduce, for example, dimensionality in the data zone, etc. And one important ingredient of our platform is also the capability to present information after being filtered and processed by the platform through XR interfaces. So again, these are some buzzwords that I mentioned previously as very important ingredients, core ingredients in the platform. The diverse pilots that we have been specified from the very beginning of this joint effort, really diverse. We're moving from personalized healthcare to serious planning, to food security, to the monitoring of environmental pest activities, to crisis management and assistance to first responders. So this is really a diverse, quite diverse set of applications. Our contribution here is not only to allow the development of new applications, but also to allow existing applications to scale up, to use more data, as this can be easily fed into these applications by our platform, to allow more complex processing, more elaborate processing to take place, and thus improve the quality of the output of these application sources. Quite a few existing sources, but also upcoming sources like, for example, Destiny kind of input that was mentioned previously by Vasilis. So again, more information on that. I guess that even through the list, it's quite obvious that we are trying to glue together and ease access to many different sets of data. More detailed information about the staff, which is supposed to be built, reside within the processing infrastructure of EO4EU, graph-based knowledge graphs that are supposed to, as I said, to ease the access to the sources, but also to sufficiently model the things that have been done through the platform and allow the future use of this information to be done in a more efficient way. The pipelines, that machine learning pipelines that we intend to allow through the platform are will try at first to train models that would improve the processing of the Earth observation data, and then use this information in order to feed the applications with all the required data. Compression, I said that we are facing a very important issue here with the large volumes of data, etc. So it is our intention to try to mobilize many different algorithms and put them together in an effort to reduce the volumes from the source all the way to the application, but also have the opportunity to focus on really the really required aspects of particular images or particular data that would prove beneficial for a specific type of applications. Fusion Engine, again, capability of bridging together different sources, heterogeneous sources, but also feeding in enriching all these data stream with in situ data. Finally, the things that we would do either as components or as models, etc., will reside in a place where new parties should be able to access, cherry pick the things that are of interest to them and try to orchestrate them in a new workflow, in a new processing stream that would feed their own application. So the vision of EO4EU is to establish this, what we call a marketplace, where all these items are to be registered and be accessible for future use. This is one important aspect of the project that shows that the character of the system that we are pursuing is generic enough, reusable, and could easily facilitate the development of new applications. We're not restricted to only those 7 verticals that were shown previously. In order to, in EO4EU, we are running all the way, meaning from the sources to the delivery of the information and the feeding of very specific customized applications. So in order to be able to cope with the load that this thing introduces, we are applying new architectures, like, for example, the more modern architectures, like, for example, the FAS type of processing, function as a service, serverless architectures that would be able to immediately respond to the volumes that are somehow induced into the platform. So we're dealing also with the systems-oriented aspect, which is of increased importance here. And in addition to that, we have our very specific data processing steps, whereby data can be retrieved, staged somehow, indexed, and then delivered to the applications. Again, on these data processing kind of activities. One important ingredient that was the orange strip on the left-hand side of the original figure that I provided is the domain-specific language, which is an orchestrator given to the hands of the developer of the In order to be able to combine all these things that were developed in a generic way and be able thus to feed applications or to provide the upper parts of the architecture, the customer-facing parts with the required data. So this is a sort of this is a mechanism that allows the user to combine all these things within our platform in order to deliver the really required outputs. Graphical user interface, I think I have already described that. We're discussing about different aspects on graphical user interface, being able to meet the requirements of, again, of a wide range of requirements for visualization in the very specific data, processed data, be able to visualize the output of analytics functions that we intend to integrate into the platform, but also feed the augmented and virtual reality interfaces that we are going to provide. Like, for example, here we have very specific ideas of how this information can enrich a VR interface on an AR interface, and thus allow the immediate use of this data while in the field, for example, where some interested party is in the field. This is quite similar to the figure shown previously by Vasilis. So on the existing status with respect to the observation data lies on the left-hand side, and on the right-hand side we have the mature processed outputs that EO4EU is to deliver. In terms of the timeline of the project, we have a very intense work plan here. Projects should be delivering outputs, or better conclude in 3 years' time, starting from June 2022. Technical activities are already underway, and the things that we have been discussing here have matured enough in our design process, internal design process. And as soon as the first outputs are being delivered, the part of the work within the project that deals with the verticals, with the applications, the 7 applications that we listed here, will be kickstarted in order to show that indeed the merits that we were considering, we were thinking of from the beginning, are there and are available in the platform. Since this is the wider community, it would be nice to hear that we have already defined certain ways that external parties not connected somehow to the consortium could come in before the conclusion of the project, before the end of the project, and try to see the things that we have been doing, try to exploit them in order to build their own applications. So we have, for example, prescribed certain contests that would allow some SMEs, for example, to try to use the software tools that we have been developing for their own applications, and these there will be technical support to do that, and of course the operation support afterwards in order to have their applications running for long. So this is it from my side as a rapid, very brief introduction to the project. Yeah, Rob, back to you.
Thank you very much, Status. So as we've seen, really relevant functionalities, really relevant platform coming soon. And now to see more in detail how EO4EU will really bring this forward, we'll go into our panel discussion soon. But before that, we'll hear first from our technical work packages on what exactly they're going to be doing to achieve all the nice functionalities and benefits that the EO4EU platform will provide. So first up, we have Jota Lily, who will describe to us the requirements elicitation and conceptual framework specification work package. So Jota, you can now share your screen.
Thanks, Rob. Hi, everyone from my side. Yeah. So I guess you can see my screen, right?
Yes, now you can put it in presentation mode. And
great. So myself, I represent EBOS Technologies. I will be the responsible leader for the work package 2. As Rob mentioned, is the requirements elicitation and conceptual framework specification. Basically, work package 2 is the work package that gives, let's say, the floor to the rest of the work to be started and implemented. So in such a case, work package 2 is it's the way we collect, we extract, let's say, the relevant user requirements and the system characteristics based on what Stathis and Vasilis previously said. So the main aim here is to focus on to all those structural and technical components that need to be analyzed in order to help us finalize the architecture, the interfaces, and as well as the integration, of course, requirements of our data ops ecosystem. So what we have here is a timeline. You can see that work package 2 starts from month 1 up to month 24. Briefly, we have 4 deliverables. We have 1 milestone to be delivered, and we have 3 different tasks. So there are 16 partners collaborating in order these 3 tasks to be implemented successfully. And to go into detail on what these tasks are and what is about to be implemented soon as, let's say, some draft ideas on what the consortium is discussing on at the moment, is the task 2.1, which is the multidisciplinary landscape analysis and the best of breed technologies. Sistema from Austria is responsible from this. A brief, let's say, preliminary idea on this is that we're going to have a survey. We're going to contact the survey to collect technological needs and to basically focus on this project research area that the focus is based. The project is focusing its innovation strategy. So in the current moment for task 2.2, which is the multi-stakeholders requirements analysis and business process modeling, the European Center for Medium Range Weather Forecast, Vasilis, who presented earlier, in collaboration with the respectful task leaders, will proceed with the collection and analysis of those end user requirements and operational procedures that are relevant to the use cases that we focus on, and the project areas, let's say, the project research areas that we focus, let's say, throughout the project lifecycle. I'm going to elaborate later on next slide concerning these. And just to give you an idea on what has been discussed by the project coordinator concerning task 2.3, about the technical specifications, the interoperability requirements and scalability analysis. We will focus on the conceptual design of the architecture, later on the logical and the physical levels of the architecture. We will identify different components, let's say, on these different business scenarios that match, let's say, our use cases with the end user needs and requirements. And of course, we have, as the previous speaker said, we have data pools, we have existing data resources. But we also need to acknowledge other Earth observation projects and relevant Earth observation data, how we can access them, how we can integrate them and compress them in the platform. So what are we currently doing? What are we currently discussing on is that there is a preliminary version of the user requirements template that the consortium is working on. this is, let's say, some pictures on to help you understand of the different terms and what are relevant on. We have 7 use cases as what has been discussed on. So the idea is to match each use case with the end users in order to be able to extract their requirements and the needs. So we thought that it would be nice to have one template, let's say, representing each use case. So this is the template for use case 1, which is the Earth observation for personalized healthcare services. And here idea is to have a brief description of the objectives on what the use case is about and relevant information. And then we proceed to general information, for example, who is completing this template? What are the technological needs that we focus on? Also, what are the end user groups? Are the internal, external? Also, an idea was to focus on different, let's say, to have 2 versions per template per use case. One corresponding to the external end user groups, and the other ones to the internal end user groups. Internal can be considered those end users, let's say, that are highly relevant to the that they're responsible for to deliver the use cases, for example, and so on. We have different, let's say, target groups. We have business requirements, what has already been identified throughout the project so far, which are breakdown into technical requirements, meaning functional and non-functional requirements. An example you can see in the screen, classification, the requested, who let's say, can help us define these functional requirements, the relevant involved, if you like, end user group, and so on. We have different storyboards to help us understand and identify the process, how we're going to extract these, and how, for example, an end user can navigate into the platform and have access to specific data. Speaking of data, we have, of course, a data specification, also different challenges, risk and assumptions. What are the mitigation actions that we're going to focus on to overcome successfully these challenges? KPIs in case that an internal end user is completing these templates. What we would like to see as a final, let's say, result. And of course, we have the maintenance tables for internal use. This is for those who, the maintenance tables is basically for the consortium to help us better understand how to collect, let's say, what is reflected on the internal and the external end users, as those that we should, could, and must have in the project, let's say, in the respective process. So that's all for me. Thank you very much.
Thank you, Jota. Next up, we have Dr. Vasilis. So once more, we shall hear from him, but this time on the data orchestration and machine learning work package. Okay.
Mute myself. Okay. Now probably you can see my screen. So this is the work package 3, which is one of the core work packages regarding the data orchestration and machine learning part, because it includes all the development and design of the project. So there, actually, I removed the center point of the diagram of EO4EU. And actually, this is what exactly what we're going to do. So we're going to stand the whole EO4EU platform is between the data sources and the end users. And we try to abstract the access to these data sources and make available the data to the end users. This is more or less to remove or make the individual silos and data coming from these repositories available to the end users. So we have in this part, in this work package, we have the semantic annotation of and with knowledge graphs and respecting the fair principles of data. And we, as Stathis mentioned before, some cutting-edge technologies for function as a service and machine learning pipelines to actually gather data, compress data, and make them available to the end users. The same work package is also not only the models to reduce the volume, but also have also the customer-facing services that with all the different access methods from APIs, CLIs, and CLI and graphical user interface, but also domain-specific language that users can use to define their workflows and the data that they would like to access, or even the machine learning models that they would like to apply to their model, and then they get the data from the platform. This is more or less the functionality in a nutshell, and as you can see in this picture is from left to right is what is the placement of EO4EU architecture and platform. So this is more or less in nutshell, and all the different parts that they're going to be deployed and designed and deployed in this work package, from the knowledge governance and smart implementation. We have also the part of the system and services where the data fusion adapter, the machine learning models, and also the functional service as I mentioned before. We have also the machine language processing with the pipelines, but the generic pipelines to accommodate any user requirements, not only the specific ones coming from the existing use cases, but also designing also for the future. The customers machine learning models to provide data to the work package 5 use cases, the data reductions, and also all this orchestration together to actually make all this available from the data sources to the end users. And customer facing is again is the front end of the platform, so as the users with the command line, with APIs, with also single sign-on and cloud security standards for authentication, authorization, and accounting, and also the XR interfaces and automatic generation of virtual reality interfaces for data injection. And this is more or less in a very quick run of these things that are core of the work package 3 and also for the project. And that was all from my side.
Great. Thank you very much, Vasileios. Next up, we have Giuseppe Trotta from Cineca, who will talk about the data marketplace ecosystem work package. So Giuseppe, you can now share your screen and unmute. If you're having difficulty, I can also share your slides.
Yes, please share my screen because I need to give some permission from Mac. Please.
No worries.
And
okay.
I can see you went to move to next.
Yes.
Thank you.
Okay, just give me a few moments and okay.
Okay, in the meanwhile, I can start maybe.
Yes.
Because we are a bit late. So yes, so yeah, my name is Giuseppe Trotta. I'm a software architect and DevOps engineer at the HPC department of Cineca. In my presentation, I'm going to briefly summarize the goal of the work package 4. But before doing this, since Cineca, we make available and provide infrastructure resources to the project, I will spend just a few words about our department and infrastructure we proposing. Next slide, please. No, next, the previous one, sorry. Cineca is an inter-university consortium with different offices and headquarters in Bologna. Its member also includes several academic and research institutes. In this project, the department involved is our department, of course, high-performance compute department, mainly as a supplier of IT resources, but not only. Next, please. CINECA is the Italian National HPC Center, which aims to provide computational resources to both Italian and European researchers, and also to support technological innovation by supporting both public and private sectors like industries. The application fields on which the research focus on are many and range from numerical simulation, one of the traditionally best known tasks in HPC, and to big data and artificial intelligence, particularly in the performance optimization and processing complex neural networks, up to the most recent provision of cloud computing in the form of a service, also known as infrastructure as a service. Also, the scientific domains of application are different from material science, weather, climate, solid earth, dynamic fluid, astrophysics, etc. Our supercomputing center is equipped with very powerful supercalculators, which rank among the most powerful in the world. Next slide, please. Yes, just quickly this picture. We have several supercomputing systems, and in particular, the system we are planning to use most in the project is this one, Galileo 100, which offers better interoperability between the cloud on top left, and the proper HPC nodes. This because it's designed to share storage, guaranteeing also faster access with the SSD storage, partition, so on. And furthermore, this system also offers a limited amount of GPU-equipped nodes to be used in particular for the AI pipeline, as you've seen. And in case it's not enough, new resources can be allocated from other systems, and in the future also from the last one arrived, which is Leonardo supercomputer. Next slide, please. Okay, this is something about, let's go back to the package 4. The goal is to deploy the software solution from the previous work packages in the infrastructure we presented. And this includes component setup, integration, operational testing, performance evaluation, and the build-up of the data market as a platform, making all its function easy to deploy and access as a service using let's say a modern approach. The aim is to firstly integrate each services at component level, then ensure that everything will work as a whole, setting up the connection between components, and finally the launch of a full-scale deployment of all the components serving for the purposes of the 7th use cases pilot use cases. Looking at the picture, yeah, we saw this previously. On the left, data from different data sources goes to accelerated systems in an AI pipeline for data enrichment, and then is stored in the data lake. Very important. We manage this in our infrastructure for later access, of course, through via the front-end application you see on the right. So by using all these functions exposed as services. Yes, this is a global picture, and it's quite clear. And next slide, please. My last, yes, this, sorry. This is finally the list of the expected tasks. Firstly, extracting the specification. So just design, analysis, design task where we're getting all we need from the previous packages and define the specification for our deployments and integrations. And the second task is about data store and staging deployment and configuration of the actual deployment as the basement of the platform. And the task number 3 is essentially for everything else. Yeah, is for modular incremental integration of the different software components in the system, resulting in this serverless architecture setup and release of the integrated framework using the best practice of DevOps and MLOps development strategy. Yes, and that's all from my side.
Thank you very much, Giuseppe. And finally, we have Monia Santini from CMCC, who will talk about the EO data uptake demonstration work package. So,
good morning to everyone. I'm Monia Santini from the Mediterranean Center on Climate Change in Italy. I'm trying to share my screen first. Let me know if you can see.
We see the desktop. So
okay.
Okay.
Now in full presentation mode, right?
Yes.
Okay. I can say that the work package 5 is more on the thematic side of the project, and the objective of the work package, the main objective is evaluating the usability and effectiveness under real condition of the system that the project is aiming to release. This will be done through demonstrator depending on real installation and the usage of the system. And this will also allow to verify that the prototype meets the defined specification and it is ready to be adopted by user. This project will achieve this objective in the work package through 3 main activities. First, it will be necessary to define to the best the use case, producing technical implementation guidelines to clarify in particular requirements in terms of data, for example, the spatial and temporal domains, the sources of data, the format, the dimension, the transfer rate, and which will be the intermediate data between the input and output data. Then also we need to clarify requirements in terms of software, for example, describing the processing pipelines, including the artificial intelligence and machine learning components. And finally, we have to clarify the requirements in terms of hardware and computational infrastructure, from virtual resources to scalability requirements, resource occupation for the development purposes, but also for the successive operational phases. The first task will produce a deployment plan for each use case, aligning also to the exploitation plan for the computational infrastructure. In the second task, we have to produce a pilot plan to define the timeline and to describe in detail the execution step of each pilot, of each use case, based on the findings on the results of the product of the use case definition, the previous task. And this task will also perform all the appropriate actions for user requirement identification and also prepare the material to ensure that user to ensure the endorsement, engagement for user. This in strict collaboration with Work Package 2. Then a final task will measure the applicability, the acceptance by user, and the effectiveness for policy making by user of each module of the system and of the system as a whole. This by making large use of questionnaire, for example, besides of course face-to-face feedback collection. Okay, we have 7 use cases that were already listed in the previous presentation. These use cases are very different in terms of sector addressed, input data, and approach adopted. The first use case aims at expanding the capacity of the PASIFO model that is developed by the Finnish Meteorological Institute and is the first operational symptoms forecasting model that also include a mobile application. The aim is to enlarge the area of applications from EU also to global area, with testing in Latvia and Lithuania, thanks to involved partners. The second use case aims at enhancing the quality of information to optimize the routes for container ship voyages. So to support a planning of more efficient voyage in terms of fuel consumption, safety, and arrival times, demonstrating the capability of merging together large volume of data from meteorological to also data from vessels. And the use case will be tested along two routes. Far East and Far East to Northern Europe, and from Northern Europe to South America, and it will be conducted by Danos, partner with the support of a project coordinator. And then CMCC, my institution, together with the Sistema company, in collaboration with another company, MEO, will conduct together 4 use cases. The first one is about the analysis up to prediction of impact, in particular loss and damages for crop production and thus on food security, based on observation from in situ, satellites, censuses, and climate series. There will be also sort of suitability analysis to identify new areas with favorable climate conditions for specific crop, as well as new crops that are suitable for the new climate condition. The area will be in Italy, but with the possibility to expand also abroad. And other use cases are more related to the vegetation, soil-water interaction, and the former will foresee the application of model simulating forest ecosystem to quantify under current and future climate, as well as under different possible management options, the fate of forest ecosystem services, in particular those related to climate regulation and water cycle regulation. The latter will combine Earth observation model data for robust estimation of rainfall erosivity and soil loss by extreme precipitation events, by advancing empirical approaches with also including machine learning methods under ensemble of climate projection and land management. And pilot areas of these 2 use cases on land vegetation will be Austria and Italy respectively. Then a 4th use case from Sistema CMCC aims at delivering a service to assess and predict the impact of locust spread, combining together especially Sentinel and climate data by means of artificial intelligence and machine learning. And different regions in Sub-Saharan Africa and the India region will be considered. Last but not least, the 7th use case will pursue a better exploitation and use of Earth observation dataset to be used in all phases of civil protection operation, with focus in this use case on wildfire and earthquakes in Sicily. This is led by IES company, that is Intelligence and Environment Security Company, and will consider the participation of many partners for the project. This is all for me.
Great, thank you very much, Monia. Now, unfortunately, we're out of time, but that ends our presentations part of our webinar. So now we open the floor to questions. Perhaps if you have a quick question, maybe we have time for maybe 2 or 3, just to extend it. Just raise your hand. You can find that in your Zoom platform, and then we'll give you the floor. Otherwise, you can also use the chat section to type in your question. If you have any for our panelists. Okay. So I see, in any case, there are no questions yet. Okay, I see we have one. So Andreas, I'm giving you the permission to unmute. You may ask your question now.
Yeah, thank you very much for the webinar. It was very interesting. Just a note from my side, the chat was deactivated the whole time. There was no way to add questions there.
Yes, but you can. Yes, we're managing it through the what do you call this, the chat. So, but in any case, if if you have questions, feel free to type them up there, or
Yeah,
even.
but it was not possible to type any questions in the chat. It's
I see.
deactivated.
I see. Okay, sorry for that. But in any case, feel free to state your question now. If you have any, please do raise your hands. Okay, I see. In any case, there are no questions for now. Okay, we have one from Gregor Bayerle. Gregor, can you please introduce yourself really quickly and state your question?
Hello, everyone. Do you hear me well?
Yes.
Okay, wonderful. First of all, thank you very much for the interesting presentation. I am a data scientist and researcher at a small Austrian business. We're mostly working in the energy sector, and this already leads me to my question. So would you be open to also open early versions of the platform for maybe external users who are not in the first 7 use cases you proposed? Or is this something you're not like really wanting because this would break the scope of the platform you're building at the current stage?
Well, can I take that, Rob?
Yes, please go ahead.
Okay, I think it was in my last slides where I have presented the opportunity of engagement from non-consortium members into the process of using the platform and trying to introduce new applications that are trying to leverage the underlying mechanism, the machine learning, etc. So yes, we're open to that option that you have just stated, and we will be happy to discuss the details. Originally, the idea is to try to set up a certain contest that was also listed on my slides, but okay, we can discuss other options of engagement as well. So feel free again to contact me and in order to try to see the details of this thing.
Thank you very much. If there is no other question, may I state another one?
Yes,
Sure.
please go ahead.
Just because I was wondering about processing, in the architecture slides, I saw like the general like setup, how processing would be happening on the slide. Maybe I've missed it again, and I'm very sorry for that. But have you also considered the possibility of using like currently emerging frameworks like OpenEO to like pass certain processing to the locations where the data already resides? Like you get data from a certain DIAS. The DIAS also has processing capabilities. It has a like front end for, or like a capability layer for OpenEO. So the function as a service, which is currently handling my processing needs, actually passes some of those processings back to the DIAS and returns only the results as like on the unified surface of the platform you are proposing.
So Liz, you want to take that?
Yeah, actually. Yeah, first of all, yeah, very good question. In the design, actually, it was not elaborated in the level that you were expecting because, yeah, we cannot mention everything. Yeah, the idea is that, first of all, the basic concept is to process the data closer to the source. So as Isidro, probably you know that we are partners in one of the DSs with you. So part of the EO4EU will be running on Wikio infrastructure that would be closer to the data repository coming from Copernicus data and Copernicus services. And this would be actually the first part that we're gonna enforce some compression, that we move this data to the core platform of EO4EU. So yes, the answer is yes. And regarding Open EO, yes, we are aware about that, and we're going to incorporate that in our design that is going to be and in the platform. It's all
Thank you very much.
OpenEO and .cloud and OpenEO.org, both of them are in the scope of our design.
Thank you very much for the clarification.
Thank you.
So just to inform everyone, the chat has been enabled now for all. So if any of you have any questions, feel free to funnel it through that. Otherwise, we also have the raise hands function in the Zoom platform. So feel free to send in your questions. Otherwise, if the question comes to you later, feel free to actually also contact us through our website, EO4EU.eu. So you can send us and contact us through the contact form, and we'll send it to the appropriate person within the project. Okay, so I see there are no more questions, and we are running a bit. Oh, we have one. So we have a question from Jacopo Ferrario. So amazing, thanks. If I understood well, you said your end users are also policymakers. Are you going to collect product requirements from them? So Jota, I think this is for you.
Yeah, so basically we have different kind of end users, from policymakers to developers to IT to general public. It's basically people that they can improve their decision making, but also their everyday lives through the data that we can offer in the platform. So there is a wide range of end users that we're going to, let's say, include in the process. This is something we're still trying to define on. Concerning the different groups, but policymakers are one of the main end users that they're going to participate along the way.
Excellent, thank you very much, Jota.
And they reflect also the use cases, of course.
Okay. All right. So, are there any other questions? Okay, well, in any case, while we're waiting for some questions to come in, just a reminder for all, we have our EO4EU community. So please join that. So if you land on the website, you can join, and that's our newsletter. We only send it once in a quarter, so it's not very annoying, and we only send it to you when we have something to share. It will also be, anyways, one of the sources for us of contacts in case you would like to engage further with our stakeholders. So just be sure to subscribe to that, because we do have more webinars coming soon. And as mentioned, you know, we have the EO Innovation Contest and a lot more interesting things coming up. Right, so I see there are no more questions so far. I think we can close here. Thank you very much, everyone, for coming here, and it's been really great. Perhaps some last words from Stathis, our coordinator.
Thank you all for being present. I see that there is a lot of interest in our job, although it's the first steps within the lifetime of the project. We hope that this effort will be successful. Okay, those of you that are interested in getting somehow involved in the overall activity, like for example Gregor, please feel free to contact either me or Vasilis in order to manage all the technical details and stuff.
Thank you very much, everyone. Have a great summer, and looking forward to see you in our next engagement activities. Thanks, everyone.
Thank
Bye,
you.
everyone.
Bye-bye.
Thank you. Bye-bye.
Bye. Have a good day.